So now we have a server. I have it here running. So I'm running Photoblog. This is a program on my computer that's listening on a port for HTTP traffic. So how do I make it more like an actual server? The way I do that is, first of all, I have to change the port, right? So if I go to my Photoblog, and like I said, the default port for HTTP was 80. So I make it listen like that instead. So let's do that. This is probably not going to work on my computer, but we'll see. See, it crashed. Why did it crash? Well, we didn't get any error here because I didn't save it. So good practice to get the error from the listen and serve so you can see if it happens. And what we'll see is it'll say something about admin privileges probably. Permission denied. So the reason why that's denied is that you have to be an admin in order to bind to port 80. Okay, so now it's listening on port 80, and the way you reach that is you just get rid of the :8080. Okay, so that's step one. Step one is to bind to port 80 for regular traffic and 443 for HTTPS. Okay, so from this step, it gets more complicated. So now I have a program that's running. It's running in a terminal, but I need to run it as sort of headless, okay? In other words, meaning I'm not running it, my computer's running it. I need to run it as a service, so that's the term they might use, okay? And so I have on my computer lots of services. If I open Activity Monitor, in Windows you do Task Manager, you can see there's, hundreds of processes currently running. Most of these are in the background, just always running. And so we need to make it like that. I'm not going to show you how to do that in OS X because nobody runs servers in OS X. Nobody has like an OS X machine in the cloud running their server. They use Linux usually. Now there are Windows machines running servers, but I'm also not going to show that because I don't have a Windows machine. So I'll show you how to do it with Linux. And so I'm going to show you the full sort of, this is how you do it. The point here is not that I'm teaching you how to do it because we're not going to need to do it. We're going to be using App Engine. The point here is to show you what it would look like if you didn't have App Engine, which is in and of itself going to be an argument for why you might want to use App Engine, okay?
So don't get freaked out when it gets...
When this is like an absurd amount of over thing, So I'm going to try and log into DigitalOcean here. DigitalOcean is a cloud provider. And they allow you to spin up a new, what they call a droplet. It's a virtual machine. It's a machine that you can rent. It costs $5 a month. It's very inexpensive. And so I have 3 of these running. And these are servers that are hosting some websites that I have. In particular, runs the Golang book website, okay? And I gave them very creative names, M01 and 2 and 3. But, so we have these servers, droplets, and these are all running. Let's see if I can, it's hard to see that, it's really light. They all are running Ubuntu 15.04. So this is the latest version of Ubuntu. If you're not familiar, in Ubuntu, the 15 means the year, the 04 means the month. So, very recent version of Ubuntu. And you can see the details about it, 512 megs of RAM and 20 gig SSD. So it's not like a super powerful machine, because this is the lightest one, which is $5 a month. This is the IP of the machine, okay? And so in order to get access to the machine, we use a tool called SSH. So I say SSH in the IP address. I think maybe it's, yeah, I had to log into root. And so now I'm inside of the machine. I've logged into the machine. And you can see that, it tells you information about the machine. This is the last time I logged in, was from Austin, because I was there. And so, but SSH is a really cool program, allows you to access the machine remotely, securely. And it uses keys. So I didn't enter a password. It used keys to do that, which is really cool. Super, super secure. And so I can see on here a bunch of information. PS will tell you the list of processes. And so you can see everything that's running. These are not running a ton of things. In fact, they're only running these things. The rest are all the built-in stuff. And so these are the website processes. So the www here is what I call, it's like the photo blog process. It's the same thing. It's a process, a Go web server, okay? So let me show you that code just so we can see it. So I have in here remain Go. And down here I have listen insert. Does anybody remember what this does, the 127.0.0.1?
Localhost.
Yeah, that means that only traffic from the local host can access this port. That means I can't go to golang-book.com:8002. I can't get them. Only traffic from the local host gets here. Okay? But otherwise, that's very much what we've been doing, right? Very similar. In fact, all I did was make a special register function. And the reason I did that was because I did several transitions of the book website, and I wanted to make sure that the old URL still worked. And so you can see I support all these variations. You go to / you can add .html or HTML or don't have it or do have it. I mean, it does all the variations. But otherwise, it's doing the same kind of, here's the pattern, here's the handler kind of thing, okay? And these are pretty simple. There's a lot of handlers in here, but I just wanted to show you that's what, I'm doing what we're doing, so I built it a very similar way, okay? And so that's this process. That's what this guy is. I compiled him for Linux and uploaded him, and that's what's running. So, but notice I'm listening on port 8002. Why am I not listening on port 80? The reason I'm not listening on port 80 is because I'm running HA proxy. So HA proxy is that load balancer I was talking about. The reason I'm doing that is I have two websites running on the server. In other words, I want two domain names to point to the same machine. But you can only have one process listening on port 80. So I have to make a process which listens on port 80 and based on the domain name you come in, routes you to the right process. So if you go to golang-book.com, you go to this process. If you go to badger.com, you go to this process. Okay, that's the idea. And that's what HA proxy will do. HA proxy is very fast. It's very good at this, so there's no need to reinvent the wheel on that. We can see how it does that by looking at HA proxy config. Okay, and it has its own syntax and stuff, but the point being that it's telling you which one to go on based on what came in. So anyway, that gets very complicated, but notice it is binding port 80 here. But I just wanted to show you that. And then the other thing I'm running is a program called Console, which is a really interesting program. So there's a company called HashiCorp. And HashiCorp is sort of a really, like they're brand new and they do all kinds of cool stuff. And one of these things is called Console. It's one of the products they make, which is a fairly recent product. I think it's less than a year old. And so it says service discovery and configuration made easy, distributed, highly available, data center aware. And the idea is that I'm running processes on my machines, and it would be nice to have alerts and notifications if those processes go down, if my program crashes, if it's not reachable, that kind of stuff. And so Console gives you that capability. And in particular, it can send Slack notifications. Oh, I guess I don't have Slack on here. And so if a machine goes down, it will send a message to my Slack room. You guys are using Slack, like HipChat or any of these chat things. And it'll send a little message to be like, hey, your server's down. Right? That's kind of cool that I can know that from Console that my servers went down. And so that's an example of one of the kind of programs that you can use to do that. It's to manage your processes. It also, I think, will start them and stuff. But in general, we use what's called systemd. Okay. And systemd is the default service manager in almost all versions of Linux now. So Ubuntu just switched to systemd. Now, systemd is hated by many sysadmins. They just hate it. But it is what it is. It's what everybody's using. So we can use it. And the basic idea is that there is inside of, let's see if I can find it. system. Yeah, I created these service files. So let me, and inside of them, it describes like how to run my program. So it says, that's the program to start, there's the working directory, and if it crashes, restart it. And this is what in Linux is very much like how we start services in OS X. In Linux, you use systemd to start services. And so in other words, the process was I uploaded my binary, I created this file, I told it to start it, and now it's running my service. So it's running in the background, ready to accept connections, and that's how you create manually a server. You go to, you buy your virtual machine, you log into it, upload the files, and then create these services. And it's a very tedious and error-prone process, but that's how you have to do it. This is why in many companies, they have an operations team. They have a team that's probably nearly the same size as the engineering team, whose sole job it is to configure, to buy hardware, to set up firewalls, all that kind of stuff, okay? The operations team. Because this is a lot of work. It's not trivial. It requires a lot of work to make it happen. So yeah, now as far as how do I get the files there, I'll show you that too because it's kind of fun. So I have made, I think in here, I wrote a little program to do it. Yeah, and so I wrote a little Go program. Here are the machines with their IPs. And then what it does is it downloads console, it unzips it, it downloads, so it does much of that, and so then it gets HA proxy and builds it. This takes like 20 minutes. And so what it's doing is it's dumping it in the temp folder so it doesn't have to do it twice. But then it downloads a bunch of other things, installs them, and then it SSHs into them and uploads them. If I can find that here, rsync. So it'll copy all the files from my machine to the remote machine. But I'm just scripting the command line, make their rm copy. So rather than rely on a service to do this, I did it manually. Real people, what they do is they use Puppet. Okay, or Chef. Chef's another popular one. Chef. There it is. Or Salt Stack, or a bunch of others. This is what DevOps people use to manage infrastructure, or programs like this. And they install the software necessary to run it and all that kind of stuff. Okay, finally, have you guys heard of Docker? Yes. Okay. Docker is also a part of this sort of ecosystem of how you run services. Docker makes it so that you have your machine and you can run sort of smaller machines inside of it. And so they can have everything they need to run inside of their container, and then you just start the container. So inside of that container, you might have installed Ruby or Python or something. You might have installed system libraries like OpenSSL or say a MySQL library, all these kind of things. But they wouldn't be installed in the outer system. And so the reason why people like Docker is it makes it so that if I have a container, I have everything I need to run the container in the container. And so if I'm like an ops person, I don't have to go to you and ask you, what do you need installed for your software to run? Because the ops people, they don't know that. They aren't writing the code. They're just starting the machine. They don't want to have to know that. They just want you to hand them the container and say, run that. And I'll be responsible for what's in the container, but you just need to be able to run it. And so they like Docker for that reason. So in bigger companies, you'll see the use of Docker. So as for once you get to a certain size, what do companies do? So if they're smaller, they'll probably do something like I'm doing. Manually manage the machines. So what happens if, if my machine goes down, if one of these goes down, which remember I told you they will go down. There's just basically no guarantee that these machines stay alive forever. So what happens is, well, one, I have 3 of them, so I'd probably be okay, because I lose this one, but these 2 are still active. But if that doesn't happen, I have to create a new one, redeploy to it, get everything set up again. Okay. So that's a tedious process. It's tedious for three things. If you have thousands of machines, that's a real problem, right? Because now you have to know where they all are, you have to know their status, all of them. It can grow quickly out of hand to manage them. And you have to remember which ones are running which things, you know. What's M1 running? And you have to know which websites it runs. So a lot of companies are moving towards a model where they use something like Mesos. And so that's Apache Mesos. It treats your whole data center like one really big computer. And so a single pool of resources, and it has all this intelligence about knowing where to put applications and stuff. It's like it's put an intelligence. Imagine IBM Watson running your data center, and that's the idea. So he's like, oh, that machine's not being used. I'll move this application over there, reroute all the traffic to it. And so he's doing what you would do manually for you. Okay. And Google has a program called the board, like from Star Trek. So this Mesos is kind of like an open source version of that. And that's what large companies use. Because like I said, they have thousands of machines. And so, anyway. So this is a very tedious process, and it's not one that I find particularly interesting. I mean, it's cool, they have to log the machines and run commands, but I'd rather just not have to deal with it, right? And so, for me, I like, oh, I want to write my program and have somebody else worry about how to run it. And that's where App Engine can fit in to the ecosystem. So, any questions about this?
You can't take your package of everything that you put in there and just back it up periodically and then plug it back in and say it's a tedious process if it fails to...
I mean, it's a manual process. So something like Mesos, oh, the box went down. It's like the Watson. He's just sitting there and he's like, oh, I'll fix it. And nobody has to touch anything, right? That's a beautiful thing. Because, you know, I wish that machines would break 95, but they don't. They break at 2 in the morning, and then you get a page, and you're like, oh, I gotta wake up and fix this. And even though it may only take 10 minutes, it's just 10 minutes out of my schedule that I'd rather not have to deal with. And so, I mean, I don't mind because I don't have serious, okay, the site's down, who cares? It's not that big of a deal to me. But if I were running a real web app, it would be a serious investment to have to like be always on. It's like you're the doctor getting paid. That's what it feels like. And so, yeah, that's why it would be tedious. Any other questions? Yeah, so I just wanted to show you that other side. That's an important part of it, right? Like, okay, I built my code, but how do I run it? And like I said, we're not going to do this manually, but you could. Now, one thing that's really cool about Go is actually doing it manually is not nearly as painful as it is in most other languages. And the reason why is, when I built this binary, I don't have to have anything installed on the server to run it, okay? Now in Node.js or Python or Ruby, I have to install Node.js on the server in order to run a Node.js application. That doesn't seem like a big deal until you start dealing with different versions. So for example, Ruby has at least 3 or 4 versions that companies use. Which version of Ruby do you install, right? How do you keep it up to date? How do you deal with dependencies? So it's not enough just to install Node. I have to install all of the dependencies of my application with NPM, right? And you can just keep going down the things you have to have installed. And so what's cool about Go is I just have a binary, and I copy it to the server, and I'm done. I don't have to worry about all these dependencies, because all the dependencies are inside of the binary. Okay? Though I will say in this case that's not quite true, because this is an OS X binary, not a Linux binary. So I'd have to compile it for Linux, which incidentally is actually not that hard. Go OS equal Linux, go install. So it's not that bad, right? That's about all you have to do. So that made a Linux binary. Now I put it in a different folder, but otherwise it's the same thing. So any other questions about this?
Is Go OS just a built-in command, or is that a...
Yeah, it's part of the Go environment. And so it defaults to your operating system, and you can change it. And then when you run like Go build and stuff, it says, oh, I'm going to pretend like you're Linux because you said you were. And so the tools will build a binary that's compatible with Linux instead of one that's compatible with OS X is called Darwin, and Windows is called Windows. So. You can also change the arch. The arch is like 32-bit or 64-bit. I've never needed to do that, but sometimes you might. Though it is becoming, now that Go's going to start being able to do mobile phones more, you may see that more, because then you can target ARM instead of x86. But that's called cross-compilation. That's all it is. Yeah?
Yeah, I was reading about using Go, the Android NDK, and you can do Go OS equals Android,
Mm-hmm.
and it'll just make .so files that you can use the Android for.
Yeah, they put a lot of work into it. I mean, it'll be ready, I think, November, but it's already usable now. It's just in beta. But they are putting a ton of work into making that process as easy and painless as possible. Because if you've ever tried to do, well, I know you've tried doing Android, the installation is absurd. You install like 1.5 gigabytes of software just to run Android. It's crazy. And so they have like a Go Mobile. You say like Go Mobile install, and it does it all for you. You don't have to like go to a website, download anything. It's as easy as Go Get, except it's building Android apps or iOS apps the same way. So that'll be cool. Okay, so I think we'll take a 5-minute break and then we'll come back and talk about something else. Okay?